All right, so on Roman numeral 23, page 13, we're going to talk there a little bit about rational equations. Rational expressions were the expressions that had an x expression on the top and an x expression on the bottom, polynomial over polynomial, another way to put that. And so rational equations, same thing. You've got, basically what it means for us is we're going to have an x in the denominator, some type of x, at least in one of the denominators, probably more than one. So on the notes there, one thing it mentioned is use proportion concept. So a proportion is just two fractions equal to one another. That's what a proportion is. And so let me give you an example there, what it's talking about. Bottom of page 13. This isn't on there, but it's what's discussed there. All right, so we're going to do a couple of these, solve an equation like this. 2 over x equals 4 over x plus 3, but that is a rational equation because the x in the denominator is why it qualifies for that. And so, what it means by use proportion concept, so the nice thing about having it in a proportion like this, we have one fraction equals another fraction, unlike the other one that we'll do in just a second, is all you have to do is cross multiply. Probably done that before. To solve proportions, yeah, you just cross multiply. So the same would apply to a rational expression like this. Just cross multiply, which means take the numerator of the first one times the denominator of the second one on the other side. So we're going to do 2 times x plus 3. And then vice versa, do the other cross multiply, 4 times x, 4x. And so yeah, it's a fairly simple solution here to do that, or to get it where we can actually solve this. And those two are equal, so that on a proportion, those cross products, they say, are equal. And so we can use that to our advantage. So that just sets up, in this case, a linear equation. There'll be times when it won't be such, won't be a linear equation, but, and so yeah, just do the solution there. So distribute, so you got 2x plus 6 equals 4x, and that's what it mentions, isolate the variable before this. So I'm going to subtract 2x to get the x's on that side. And then divide by 2, we've got x is 3. Now, you remember we talked about the square roots. You had to check the answer when you solve those. Same thing here. So what you want to do is check for non-solutions that make the denominator 0. So we're looking for values. So we want to check to see if this makes, in the original equation, a denominator of 0. Because what if it makes a denominator of 0? That's bad, right? You can't have a denominator be 0, and so you have to throw that one out, like the square root one. If it didn't work, you threw it out. Same thing here. And so looking back at the original denominators, does that x is 3 give us a denominator of 0? No. We'd have a denominator of 3 and a denominator of 6, so it's okay. It checks out, okay? Like I said, if it does give me a denominator of 0, throw it out. And we'll probably come across one. I think the plan is to have one that does that. All right, so, yeah, and it mentions, that's the very last bullet point there on page 13. Don't forget the denominator of a fraction cannot equal 0, so yeah, check to see that it's not excluded as a denominator 0. All right, so that's the one type. Probably, you would probably say the easier type, because the other one, it's not too bad, but that's on the third bullet point. We'll tackle one of these. Multiply the equation by the common denominator and then solve the resulting equation. Here's one where that applies. All right, so we have 3 over x plus 1 plus 2 over x plus 4 equals 4 over x squared plus 5x plus 4. So why isn't this one like that one? Well, you got two fractions on this side instead of just one on each side. We got one on this side, but we got two on this side, you see. And so cross multiplying, not so much, okay. So yeah, it mentions the way we do this one is we're going to multiply by the LCD on both sides. To accomplish this or solve this one. Now, do you notice something though we should do first before we decide our LCD? Factor, right? This one, we were doing LCDs previously. Yeah, if we had something denominator that factored, we want to do that. And so, first step here is let's factor our denominator there. So it's x squared plus 5x plus 4. And usually on the ones like this, you can use the other denominators to help you, but yeah. X squared, so it's x and x, 4 and 1 works out because that'll give us 5 in the middle. Yes? Okay. All right, so that does give us our LCD. So the LCD, the least common denominator, would be, what do we need for all those? Well, like I said, it's fairly straightforward here. The LCD will be x plus 1 times x plus 4 because that's what we got. All right? All right, so yeah, so this is the idea. Multiply on both sides by the LCD, and we might just state it. So I'm multiplying this side by the LCD and this side by the LCD. Basically, you're just going to multiply each part by the LCD. So I'm going to take this, I'm going to multiply it by all, because basically you're distributing on this side. Multiply it by all the parts in your equation. So we've got 3 over x plus 1 times the x plus 1 times x plus 4. And then the 2 over x plus 4 times the x plus 1 times x plus 4. And then 4 over x plus 1, x plus 4 times x plus 1, x plus 4. And so, yeah, the reason we do that is because, yeah, nice things happen. We get lots of canceling out. Since we've got that x plus 1 in the denominator here, multiplying it cancels it out. And so we just have 3 times x plus 4. The x plus 4's cancel there, so we have 2 times x plus 1. And then really nice, in this case, the x plus 1 and the x plus 4 cancels out, and so we just have 4 on that side over there. Yeah, and so very similar to what we had, just a little bit longer, I guess, than what we had previously. Just solve that out, distribute, and then solve for x. 3x plus 12 equals 2x plus 2 equals 4. Sound right? Of course, you got to combine the like terms over here. You got 5x, 3x and 2x, and you got 12 and 2, so you got 14. So 5x plus 14 equals 4. Subtract your 14. Over there. so we have 5x equals negative 10. Looks like divide by 5, you get x is negative 2. All right, so again, check on this one to make sure that if we plug in the denominator negative 2, or x to be negative 2, the denominators don't come out to be 0. And the only way, so what would it be? What ones would be excluded here? Negative 1 or negative 4? If our answer had come out to be negative 1 or negative 4, we'd have to throw that one out. But it's negative 2, so we're all good. It checks out. Okay. Any questions or concerns right there? All right, so let's do page 14 now. Roman numeral 24 has 4 examples, so let's go through those. Actually, I'm going to change a couple of these to make them work out a little bit nicer. I think the homework problems usually work out pretty nicely, but we'll talk about one that doesn't work out so nicely. So let's do this. Change a to absolute value. The square root of x plus 3 equals x minus 3. So this has a combination of the radical and the square root rational expressions. So we got to change that 3 to a 2 on example A, so it'll work out like I want it to here. So yeah, this one we talked about last time. What do we do for square roots equations? Square both sides? Yeah. So we're going to square both sides here. And that'll cancel that out, so you get x plus 3. Then of course here, you got to square that binomial out, x minus 3 times x minus 3. So that gives me x squared minus 3x plus 9. So we got x squared minus 6x plus 9 on the right. So now how do I solve that one? Well, so this has a combination of square root and an x squared equation. For this particular x squared equation, you need one side 0, don't you? We'll talk about the other types. Probably come up with other types here in a second. So we need one side 0. So let's make the left side be 0. So I subtracted the x and subtracted the 3. And so that gives me x squared minus 7x plus 6. 0 equals that. So far so good? Now we can factor, actually we can factor or use a quadratic equation here. I'm going to go ahead and factor, it's a little quicker, I think. X squared, so x and x, 6 minus 7 in the middle, so that's minus 6 minus 1. And so that gives us two solutions, x minus 6 equals 0, x minus 1 equals 0. Two solutions, x equals 6, x equals 1. Now, I say solutions, but they're potential solutions because if we go back to the original equation, let me rewrite it here. Got messed up there. Our original equation is that, and if you plug in 6, you're okay. Square root of 9, that would be square root of 9 equals 6 minus 3. That's 3 equals 3. So that's okay. But the 1, if you plug in the x to be 1, not so much because that's the square root of 4 equals 1 minus 3. That's 2 equal negative 2. So that one doesn't work. So that's, again, why you got to check on the square root equations and the rational equations. All right. That was kind of a review one for me. First one there. All right, B. Okay, I didn't need to do anything to B. All right, let's just do B. All right, x plus 2 over x plus 2. that x plus 2 over x plus 2? Okay. I just now noticed that. Well, let's just say that didn't simplify there because, yeah, we wanted to show here how this, even if we cancel it out, it would be fine, but yeah, so this one, rational one, is one where we can cross multiply. And I think that's the idea here. So cross multiply there, so you got 3 times x plus 2, and then the other one is x minus 2 times x plus 2. Which gives us 3x plus 6. And then of course here we got to FOIL this out. So you got x squared plus 2x minus 2x minus 4, and of course the middle terms drop out. So again here we've got an x squared equation, and what you do is make one side 0 and then either factor or quadratic formula. So I'm going to again make the left side be 0 minus the 3x and minus the 6. That'll give me x squared minus 3x minus 10. Which factors as x minus 5 times x plus 2, which gives us two equations. X minus 5 equals 0, x plus 2 equals 0. So we add the 5, get x is 5, and then subtract 2, get x is negative 2. Now, this is why we had the original equation like it was, because of what about one of those solutions? One of them doesn't work, does it? Which one? This one doesn't work. Yeah, if you plug in negative 2, you get a denominator of 0. Negative 2 would give us that denominator, and that being 0. And so 5, not so much. So 5 gives the denominator 7, so we're good on that one. So. All right, question or concern on that one? On to C, and C I'm going to make another change. 1 over x plus 2 over x squared. It's got 5. Let's change that to 3. Again, just so it'll work out a little more to my liking here. Can't do that in your homework, but I'll save the more complicated one for the last one. Does have complicated answers. Anyway, all right. So yeah, so this one is one compared to B that's different because it's not one equals the other, right? You don't have two fractions equal to one another. You've got, if it was just that, you know, you can cross multiply, but since we've got two fractions on this side, it doesn't quite qualify as a proportion there. So this is the one where we do the LCD. What would be my LCD of that equation? Well, I've only got two denominators. Well, that's denominator 1, so it doesn't really matter. I've got x and x squared, and so the deal on that is go with the higher power, right, for LCD. The LCD is x squared, since we got x and x squared. The LCD is x squared, and what do we do? Multiply x squared by both sides, meaning all parts, multiply by x squared. So 1 over x times x squared, 2 over x squared, multiply it by x squared, and then 3 also. Even though it doesn't have a denominator, you still got to multiply by x squared because we're doing both sides by x squared. Is that good? Well, course, what happens here, the x goes into the x squared, and that's just going to leave me an x, because one of those cancels, one of those x's in the x squared cancels, but still leaves me one, so we got x there. Nice here, that cancels. Both x's squared, x and the x squareds cancel, because you got x squareds. That's just 2 left there. Yes? And then 3x squared here. So not too bad. But again, that leaves us with an x squared equation. And again, one that needs to be equal to 0 to solve. So subtract the x and subtract the 2. Like we've always today been going to the right. And that's just because it'll make the x squared be positive, and that's usually preferred. Doesn't have to be, but and that does factor, or you can use a quadratic formula. But if we do factor it, 3x squared is 3x and x with minus 2, and just a little trickier on this one. I think you need the 2 here and the 1 here, and then the plus here and the minus here. Yeah, because that and that gives you 2x, and that gives you minus 3x, and that's where the minus 1x comes in. Or however you prefer to factor it that way. Or use a quadratic formula. Would give you the same answers. All right, then you got 3x plus 2 equals 0. X minus 1 equals 0. And so we've got 2 answers here. 3x equals negative 2. So that's negative 2/3. And then you got plus 1 here, so x is 1. So we've got 1 and negative 2/3. And I circled them, but we do need to check to see that those in rational equations don't give you denominator 0. Well, neither one of those give us denominator 0 because the denominator here is x and the denominator here is x squared. So both those are going to check. Any questions on that? All right, so D. Far ahead there. Letter D has a little bit of a complication when we get down to the last step anyway. Let's look at solving that. So this again is one where you need to do the LCD. So the LCD, it's already kind of set up for us. So x plus 3, that's just 2 totally different factors, so you need both of those in your LCD. And again, the denominator here is 1, so nothing comes out of that. And so yeah, take that and multiply it both sides by x plus 3. So you got 1 over x times x plus 3, 2 over x plus 3 times x over x times x plus 3. And then 5 times x plus 3. And things cancel out when we do that. X's cancel, so that's just x plus 3. X plus 3's cancel, so that's just 2x. And then over here, you got to distribute. Nothing cancels, so you just have to multiply those out. 5x squared plus 15x. We got 3x plus 3 equals 5x squared plus 15x, which again is an x squared equation. Leave one side 0. So let's subtract the 3x to get rid of those. This side 0. All right, so yeah, this is what I was alluding to. This one doesn't factor, and so yeah, it is a quadratic formula. To finish out this problem. So that's x equals, review do that. Minus b plus or minus square root of b squared minus 4ac all over 2a. And so that gets me, of course that's b, a, b, and c. So b is 12, so it'll be minus 12 plus or minus square root of b squared. Well, you squared 12, you got 144. Minus, let's just go ahead and write out the 4ac. So it'll be minus 4 times a, 5 times c, negative 3. So there's again our 4ac there, and then 2 times a, so it'll be over 10. And yeah, so this is not as nice solutions, is it? What do we got? 144 plus 60 over 10. So that's minus 12 plus or minus the square root of 204 over 10. And so pretty good answer. You can do a little simplifying. This one you can say, well, that's 4 is a factor, 4 times 51. And so that's negative 12 plus or minus 2 square root of 51 over 10. And then you can reduce those by 2. So you get negative 6 plus or minus 1 square root of 51, or just square root of 51 over 5. So, and obviously those aren't going to make the denominator 0, so there you go. Most of them work out pretty nicely on our assignment, so, but I just wanted to make you aware there if that happens, what happens. All right. Now in 25, I think what I'm going to do is just do the right triangle one. So I'm going to omit some on the assignment. You're going to be able to omit 23 and 24 on the homework assignment. Yeah, so in 25, let's just talk about the right triangle, a couple of right triangle problems. Yeah, so when we have a right triangle with 90 degree in it, we usually label the two sides of the right triangle, A and B, and then the other side's the hypotenuse. The longest side is called the hypotenuse. We refer to that. And these are the legs that make up the right angle there. But yeah, the Pythagorean theorem is the formula that we use: a squared plus b squared equals c squared. So let me do one before I do the A one there on 25. Let's say I've got a right isosceles triangle, and it has a hypotenuse of 100 feet. It's 100 feet long. How long are the legs of that triangle? Okay. All right. So I threw in another. In this on the homework, they have one like this. So that's why I wanted to do one. A right isosceles triangle. So isosceles means two sides are equal. And so if I draw the diagram here, my hypotenuse is 100, so I know that's 100. But then it's an isosceles right triangle, and so the legs turn out to be the same thing. And so we can just call both of those x. And so that's the nice thing about this one, the way this one works out pretty nicely. Yeah, because those two, since it's isosceles, that just means both of those are going to be the same. That's not going to be the case on the other one that we do. But this one works out pretty nicely because then our a squared plus b squared equals c squared. We've got x squared plus x squared equals 100 squared. And so that's our equation. 2x squared, yeah, we can combine those to be 2x squared equals 100 squared is 10,000 actually. And so that being just an x squared, just divide by 2 there and use our square root method. We haven't used that one today. So x squared would be 5,000, so square root both sides. And since this is an application, we can't have, it's usually plus or minus, but it's an application, so it's not going to be a negative. And let's just go ahead and just for see how that long that is, take the square root of 5,000. Calculator is pretty blinky there, you might have to help me out. Square root of 5,000, about 70.7 feet long. All right. All right, so the A one has a little different. One leg of a right triangle is 10 inches longer than the other. So let me just kind of draw it where one leg is longer than the other. So let's say this leg is X, this leg is 10 inches longer. So we can represent that as the X plus 10, and then hypotenuse is 30. And so this, we draw the picture there. This is our picture, but of course, it's still a squared plus b squared equals c squared, the hypotenuse squared. And so let's do that. So we wind up with this equation, which, yeah, unfortunately is a little more complicated. You actually have to, square this out, x plus 10, x plus 10. So you got x squared, that x squared, and then you got this x squared plus 10x and 10x plus 100. And then you got 30 squared is 900. And so on this side you got 2x squared. Add those, you got 20x plus 100 equals 900. So again, just like most of these have, we wind up with an x squared equation. In this case though, we need one side 0. So we got 2x squared plus 20x minus 800 equals 0. And yeah, this doesn't factor, and so it is a quadratic formula again. If A is 2, B is 20, C is negative 800. And so there you can get the answers: minus B, negative 20, plus or minus square root of B squared is 400, minus 4 times A times C over 2A. So you get negative 20 plus or minus the square root of, going to be 400 plus 6,400, I guess, over 4. And here's what I do with these. Like we did over there, let's just round round off to the nearest 1 decimal place. All right, and so, let's see, that would be the square root of 6,800. So let's take the square root of 6,800, which is 82.5. And then divide that by 4. And, the two answers there, this would give us a negative, so that one's not it. It's negative 20 plus 82.5 over 4. That's our answer. That would give us a negative, so was that 62.5 divided by 4? That's my answer. .6 feet or inches or whatever it is. Inches, I think. Question or concern?